Hey, happy Thursday, everybody.
Hey, hey, hey.
Hope everyone's recovered okay from Hacker Summer Camp. I know that was a really long but interesting week. Now we're back. We took a little break. We're going to get into our normal scheduled Threat Thursday lives. Except this month we're doing it a little different because of the way everything's happening. We've got two back to back. So you're going to see us today and next week talking about two completely different things. Today should be pretty cool. We're going to be talking about yet again another tale of basically supply chain compromise. DPRK is involved, obviously, so that's going to make it a little more interesting. Users getting phished, people's machines getting taken over, all kinds of fun stuff happening. So, a little backstory here. We ended up collaborating a bit with the research team over at Elastic to develop this as a threat on our side of the platform for use. So, it's really interesting what all is going on in here. Tyler, you want to break it down for him a little bit?
Yeah, for sure. In here, let me add over to the stage, zoom in a little bit. So, like I said, this is essentially a cryptocurrency stealing campaign that was done by DPRK China. So how they have it broken down is it is a safe wallet compromise, essentially. So at first they sent or first they registered a crypto domain, and then through a phishing lure, I believe they delivered this malicious Python application. Once the victim runs that malicious Python app, it's going to start up. It's going to do a bunch of stealing and enumeration and things like that. Try to access your AWS instance and get your creds, different pieces like that. Once it has your creds, be able to see some C2 traffic, some connections going back and forth between your AWS environment and that endpoint, which is a macOS like developer's machine in this scenario. So you'll see some traffic back and forth through AWS. After that, the threat actors uploaded a malicious JavaScript application. They essentially downloaded the app that the safe wallet app that that was inside of AWS, inside of that S3 bucket. They downloaded it, and then they replaced it or resynced it back up with their malicious JavaScript application, which would then intercept your traffic when you go to send your cryptocurrency. Specifically in this scenario, I think it's Ethereum. But when you go to send Ethereum to a different wallet, the JavaScript application would intercept that, change the wallet's recipient, or change the recipient of that transaction to them, and then it would send that Ethereum, that cryptocurrency, instead of from your intended endpoint to them without you knowing. And by the end of all of this, they had, as it says here, they had stolen about 400,000 Ethereum tokens. And it says, if I scroll up a little bit, that they as in DPRK's group that's running this campaign, have apparently been able to steal over $6 billion in cryptocurrency since 2017.
What's,
So
what's
a pretty huge chunk of money, you know.
What's wild about that number, Tyler, is just from this one intrusion, that 400,000 ETH comes out to somewhere around 1.7 billion US dollars.
Yeah, that's crazy. I
Campaign.
when we were looking up some more information about this campaign, I believe it was the largest recorded cryptocurrency theft ever. So yeah, pretty crazy. And they've obviously, if they've been doing it since 2017, they've been doing it for quite a while. That's just kind of the background on it. So I'll show now kind of how we emulated it. So the first step they had here was that they register, this get stock price domain. Everything that they do in this campaign and that we do is all kind of cryptocurrency themed, right? So you'll see a lot of cryptocurrency domains and applications and the malicious app that we use and things like that. But first up, we went on to Python Anywhere. I don't know if anyone is familiar with that. It will let you host a site for free, essentially, as long as you renew it every 3 months. So we went on there. We hosted this Python, this Purple Unicorn Python Anywhere site, which looks like kind of a standard crypto stock site that you have up here, right? So this is where we're going to host our some of our malware that we're going to utilize later on. So you see then that the developer has sent a phishing lure with this malicious Python application. how that looks, I can show you inside of the shell here. So we have this Monte Carlo stock investor. Let me zoom it in a little bit. There we go. So we have this Monte Carlo stock investor simulator. This is our malicious application that we sent to this developer, right? So again, crypto themed. It's all crypto themed, so it all looks pretty realistic, right? So kind of the guys behind this one is the victim will open up this app like, oh cool, it's going to help me do some kind of crypto investing kind of on its own. They run app.py, and so to them, then they see like all the stock prices coming back and forth. It's able to update them. It functions as normal. But what happens when you actually run app.py is it goes into data here, and inside of data fetcher.py, this is where we get into a little bit more of the juiciness, right? So when they run app.py, it'll still return all of the crypto information and stock information that they want, but it will also run this in the background. And what this will do, if I scroll down, is once it gets to this part here, so we're going to run a direct download. Excuse me. We're going to use this direct download link that we have here to download a campaign from Scythe that we're going to run and execute some malicious actions. We'll show here in a little bit. It's going to reach out to this crypto stock pro site that I showed us a second ago. It's going to reach out to there, and on the back end we have two kind of scripts that we wanted to run for us, right? So it's going to run the stealer.py. Stealer.py is going to do just like you would think it would do, right? It's going to steal some information. So it's going to look for AWS credentials. It's going to look for SSH keys. It's going to get some system information, your Chrome history, stuff like that. And then it's going to look at this latest.yaml, which is our it is a Python script written in YAML, so PyYAML, if anyone has utilized that. It's an unserialized version, which has been utilized in a lot of RCEs and things like that. But it's going to reach out to our site. It's going to pull down the latest.yaml or look at the latest.yaml, which is going to feed our direct download link and launch the campaign and launch the stealer and everything like that. The only change you have to make inside of our app here, this Monte Carlo stock simulator, is inside of data fetcher. You have to change that direct download link to reflect our campaign. But we'll have that here in a second. What's up?
Of note here, the actual campaign, they were using the Poseidon framework from Mythic and their C2 was what they were actually using, but we're replicating everything they were doing with that and the other YAML files, basically just through Scythe instead.
Yes. So this, we kind of had the overview. This was the other picture that I was looking for. So downloading this stock investor simulator app, again, has this data fetcher. It's going to reach out to our site and pull the latest.yaml. That's going to tell it what to execute and then load it in memory. And this init.py is where it's going to run the stealer, our Scythe campaign, get this AWS, SSH, keychain, all that kind of information in there. They're utilizing a Kali box in their instance. We run everything just on Scythe instead. And then once that's done, we will pull down the S3 bucket that's hosting this site, which I'll talk about here in a second. We'll pull that down, and then we'll replace it with our malicious app. So it's going to go through these tabs again that I had up. So this site here again, this purple unicorn Python Anywhere, is just kind of our front page where we have some malware behind it. The first of those being the latest.yaml. So this is that Python YAML, that PyYAML, that is just a Python script written in YAML, which is utilized so they can run it with that deserialized Python script. So in here, it's going to pass our direct download link and the stealer URL. So it'll execute our Scythe campaign and that stealer.py. And then I'll go ahead and launch our campaign and then talk about what that safe wallet is doing here in a second. So in our campaign, we have our profile access keys and secret access keys. These will be deleted as soon as this talk is over, so no sense to try and do anything with them. But once our campaign is run, it's going to do some more AWS credential enumeration. So we're going to list out the profiles, just run an ls on this directory, trying to see if there's any configurations or credentials or anything like that inside of it. And then we're going to send our AWS credentials to that endpoint. So those variables we had set up top, it will actually place those inside the credentials file, so we can use those to authenticate to the S3 bucket. So this would be like, this is emulating, we've stolen the credentials via whatever means, or we're piggybacking off of an already established connection that they have to AWS through the CLI, which is pretty common in, on a developer machine, right? Next up, again, just doing the profile just to make sure that what we think worked did work. And then we get into, in the emulation that Elastic had written up, the user had multi-factor authentication turned on. So we have a AWS script, or we have a multi-factor authentication script that's going to run on the endpoint to spoof some multi-factor authentication and allow us to have that connection to their AWS S3 bucket.
What's really interesting here, it was seen throughout this campaign that they attempted this to register a new virtual multi-factor auth device, so that they had access offline basically from that user they compromised, but it failed. So this was something we at least wanted to still replicate and emulate for you guys, so we included the scripts in there as well.
For sure. Yeah, a neat thing about having the AWS creds is once you have those creds, you could put them, like if they're an SSO credentials, it's not going to work. But if they allow you to authenticate just with this credentials file, once you have those, you can put it on any machine and connect to it just like you were that user, right? The only thing standing in the way is the multi-factor authentication, which was kind of trivial to create. I think it took like less than a day to create this multi-factor authentication script. But after that, so we have access to AWS, we have the credentials loaded, everything like that. So now we're going to see what S3 bucket we have the purview over, what we're able to see. We'll have this front end bucket VB, and then we'll sync that. So we'll download all of that to the endpoint that we're on, the machine that we're on. We have a malicious app that's already waiting over there. So we will unzip the malicious app and then sync back up to the S3 bucket with our malicious app, which is going to replace the safe wallet. So the safe wallet that they have now, it looks like this, nothing crazy. You would put the recipient address in there, you put the amount that you want to transfer, and it would send it over. Just kind of to show what it looks like on the back end for us. So that's just this index HTML file. And then in this, we're not going to load the entire app up there just because it's a huge application and it takes quite a while. So for this kind of demonstration, right now we just have a good.py, which is, you could imagine the normal kind of backend you would have that would perform its normal operations. And we're going to replace that with our evil.py, right, which will then intercept. Once you put the recipient address in there and hit send, it'll intercept it, change this recipient address to ours, and then we would get paid instead of whomever you're trying to transfer money to, right? So with all that being said, I think we could probably go ahead and run the emulation. So again, the only thing you would need to change to run this is to pull the direct download link. Here in a second when it loads, you would pull this, and then inside of the datafetcher.py, you would just change that URL, because these three, the stealer, latest YAML, and direct download link, is all going to be passed up to the latest .yaml. So you only have to set it here. You don't have to set it anywhere else. And then that way, we're not just leaving our direct download link inside of this latest .yaml file, which anybody can reach, right? So a little bit of a security built into it. So then we go back, and what we'll do, we'll run Python 3 app.py. We'll run sudo Python 3 app.py. All right, and then from there, here in a few seconds, we should get a check-in, and then we'll show you some of the other pieces of the campaign that are executing. So we got a check-in. It's going to start to roll in. we'll do while that's loading. So again, it's excuse me, it's going out to this Crypto Stock Pro that we have out there, this latest .yaml file, replacing these variables with the ones we had set in that data fetcher.py. And then from there, the endpoint is going to pull down the direct download link, it's going to pull down the implant, it's going to pull down that Stealer URL, run it in memory so that you shouldn't see any indication of it running. That's through the deserialized Python RCE that's available. And then from there, once it's done loading, two of them up, I should have ran this in the background. We go to temp LSA. So the Stealer.py, which I'll talk about while the campaign is running in the background, the Stealer.py will create this .loot file. So the .loot, the user it ran as, and then the date. So we see it when I was running it yesterday to do the test, I was running it as myself. But in there, I'll go into one of mine to show you. So in there, like I said, it pulled the AWS, the .aws directory for this user. It tried to parse the creds. It pulled the web browser information. So in Chrome, it'll pull your history, your logins, your bookmarks, all kinds of information like that. SSH keys if it can find it, and system info. And then I'll show you guys just what the AWS creds look like. So in here, we have some fake creds that I put in the AWS credentials directory. But in there, you can see if you have this access key and secret access key, you could take this, copy paste it into your own .aws credentials file, and then you are essentially that user, right? You now have these permissions. All right. So in that, we have some steps that have ran. So we'll look, see, just listing the profiles, see who's there, running the AWS, make sure that there's files there, pulling the environment variables. So you can also specify AWS credentials as environment variables. I think it's like AWS key or access key and secret access key, I think, are what the environment variables are. So that's another spot that they had looked for these creds in the emulation that Elastic had written up. And then from there, now we're placing our B3 developer access key and secret access key. We're placing those into the credentials file, so that way we can, I would say impersonate, but we're not impersonating. We are becoming this user, right? We have those placed, then we do a profile to see what that developer account is able to view. So we have a B3 front end bucket and the Cryptid Society bucket. And now we're going to run the multi-factor authentication script, which fails out because this user doesn't have multi-factor authentication. So it fails out, obviously, because there's nothing to multi-factor authenticate to. From there, we're just going to verify our identity. The reason that we do this is because if it's not able to pull this identity, then nothing else is going to work. So it runs that just to make sure that it's running with the proper permissions. And we run again, just so now we know that we want to target the B3 developer VB front end, that S3 bucket front end. So we want to see what's inside of it, right? So we have our index file, which is again this main page here, just for the emulation, and then inside of app, is all of the backend, processes and scripts that would run with this. That again, for this is the good.py, which we're going to change to our evil or bad.py. I don't remember what we called it. So in here, just listing the objects again, just doing some more enumeration, just seeing a little bit more. All of these \n should be carriage return, so it looks a little bit nicer, but it's all good, right? So here we have access to the S3 bucket. We know what's there. We know what we're targeting. We're going to sync down, which sync will just pull down what is in that S3 bucket here. So it's going to pull down index 1, and then our good.py inside of app. We have that. We're going to unzip our malicious app that we have there, which is again is a complete replica of this app that we pull down, right? So it's a complete replica of the S3 bucket that already exists there. We just need to change you know, the bad or the good to bad, right? The good to evil in this emulation, but you still want everything else to work, right? You still want this page to pop up because you need it to still be functional so you can intercept the money or intercept the cryptocurrency as it's being set.
And this is something that the threat actors themselves, they did over about 2 weeks. They initially did the sync down to grab a valid copy of that Safe Wallet app, analyzed it for a bit, injected their own malicious code, and then the next step here that Tyler's talking about is them doing the push back up to the bucket.
Yep.
And that basically is what's going to turn this live. And then from there, they can on the fly intercept transactions between the Safe Wallet apps and Bybit, and kind of on the fly make their changes and deceive it to make it think their transactions are valid. But in reality, they were going to DPRK instead of where they needed them to be.
For sure. So yeah, in here you see that we sync again. So instead of syncing wherever this downloaded to, so instead of syncing the B3 front end bucket back up, we are syncing it with our malicious app and then deleting the stuff that's there. So we wanted just to have our app in there, which again is just basically a one-for-one copy, just with the bad instead of good, right? So we push that up with the profile, go back to the page, see that the page is still going just fine, and then over to the application, we could see if we go to app that our evil or our good.py has turned to an evil.py, which will now run in the background and intercept your request as you're pushing it through, changing that recipient from, you know, trade.bilberry, sending it to DPRK, and then that's how they steal all your dollar bucks.
Yep. And now obviously this is kind of where that emulation ends. We're not doing any kind of real crazy blockchain stuff or actual like crypto stealing or anything like that. So this overall gives you everything on your end that you can control and potentially see on your endpoints or in your services and attempt to threat hunt against. So hey, look at that. We're just a little over time on that one, Tyler.
Just a touch over. Yeah, no detections. It's a pretty complicated scenario to kind of walk through. I hope that I did an okay job with it. But in there, I put the link for the write-up that Elastic had done. Yeah, it was a super interesting emulation that we partnered with them to kind of go and push through, from like standing up the websites to having the applications, S3 buckets, all kinds of stuff like that. It was really interesting and very different than a lot of the ones that we do. A lot of precursor kind of work on that end. But yeah, I hope from the emulation side that everybody kind of got something out of it or learned something. Highly recommend to go through that article. Elastic did a great job on the write-up, and it was a lot of fun partnering with them to put this through.
Yeah, it was definitely very detailed. And again, a shout out to Elastic for kind of collaborating with us. And also on the groups this research was based on. So that would have really been Signia, Mandiant, Unit 42, and Slowmiss. They all put out different little pieces to the puzzle here that was pulled into the amalgamation that you see it is. Last thing I really have to say or talk about is, I know you guys come and watch us. I know we put on some cool stuff. We talk about different things, but we always like having you guys on with us as well. So if you'd like to join us on Threat Thursday Live to talk about something cool, whether that's specific threats, threat actors, hunting, detections, anything within that space or in purple teaming in general, please reach out to us at ProServe. Let us know, and we'll see about getting you on and run a session with us. I think with that, we will call it a day today. Thanks for coming and hanging out, everybody.
All right. Thanks, everybody. See you next week.